Chris Bauer joining you from sunny Long Island, New York this morning, not my usual place in Houston. So I'm working with a slight handicap in that I only have two screens with me this morning, but I'll do my best to move the slides along. Today I'm joined by, hang on a second, try to get to my controls where I can switch the presentation. There we go. Today I'm joined by Bill DeWeese from Hughes Aerospace, who's going to talk a little bit at the end about the Hughes app that is free that you can use, where we have a new FOQA tool, and Bill will explain what that does and how it works, and we have a little video. I'm also joined by Corey Stevens from the FAA, and he's with the Office of Accident Investigation and Prevention. He is involved with ASIAS, which is what we're going to talk about today, along with Emily Lynch, and she's with the Office of Accident Investigation and Prevention as well. And she's with the Integrated Safety Teams branch. They both are an AVP 420. They put together a great presentation. I'll be moving their slides for them. And if you don't know what a SIAS is, don't feel bad, because I've been flying for a long time and I didn't know what a SIAS was until I became involved with it. And that's why I thought it would be meaningful to have this presentation today, sponsored by the U.S. Helicopter Safety Team. The more you learn about how this data is used and where the data is gathered from and how it prevents accidents, it has a lot of meaning. And then when we can take all this data, it helps us figure out where we can prevent accidents. And one of the areas that we're always at risk for in our community is loss of control in flight, or LOCI. So with that, I'm going to turn it over to my colleagues, Emily and Corey from the FAA.
Thanks, Chris, and thanks, Laura and Bill and everyone for having us this morning. Yeah, and like Chris has said, my name is Corey Stevens with the FAA's Office of Accident Investigation and Prevention, along with Emily. We're both out of the Washington D.C. office. I'm coming to you live from beautiful Martinsburg, West Virginia, out at the airport this morning. Emily,
Yeah, I'm from Northern Virginia. I'm in Northern Virginia at the moment, so happy to be here.
cool, thank you. And yeah, so we're going to give you kind of a quick brief on ASIAS, kind of where it came from, how ASIAS and the different safety teams do their work, because it's very closely interrelated. And then we'll kind of go into kind of the nuts and bolts of ASIAS, and how you, as a pilot, whether you're rotor wing or fixed wing, can participate, and how we do our work as a community. So, Chris, if you want to hit the first slide. So yeah, SIAS, it's a very long acronym, as you can see. Basically, it's a collaborative government industry initiative for safety data analysis and sharing, and that's just a very fancy way of saying, hey, we're, as a community, we want to take a look at trying to discover what the risks are in the system and try to mitigate those before they become something much more serious. So the goal is try to mitigate an accident before it occurs. And it truly, systems like this allow us to identify and understand what the risks are before they occur. And this fits into a much bigger picture, as you can kind of see we call it kind of our safety continuum. You kind of see our different safety teams listed at the top. CAS stands for the Commercial Aviation Safety Team. There's the U.S. Helicopter Safety Team, the General Aviation Joint Safety Committee, and also the Drone Safety Team, which is the logo you kind of see there in the middle. So those teams look at risks, develop mitigations. As a community, we implement those mitigations together. That's government, industry, everyone together. We monitor how those mitigations are working. We get together as a community to share what we're seeing in our data, and what we see coming out of those data gives us kind of insights as to what's going on in the system. Then we get together once again as a community. Everything we do together. We take a look and try to decide, is this something new? Is this something we need to be concerned about? Is this something we need to start mitigating now? Or is this something we need to monitor? Where's the risk in that right now? And then we conduct that analysis. We feed it back into the teams. If it's something that we need to work on immediately, We'll develop mitigations. We'll put those back out, and the system continues. If it's something that we just have to watch, we'll sit and monitor until it becomes something we need to act on. Next, Chris. So how this came about, it's kind of a very interesting story. I actually got to start this work back out when I was in industry. I was before coming to the FAA. I worked for United Airlines for a short period of time. I used to say I worked for a small regional carrier based in Chicago, and I said United. And then from there, I worked in engineering accident investigation at the Airline Pilots Association for about 11 years. And I began this work right as I began my work at ALPA. So I've had a chance to work this from both sides, and that's why I kind of really believe in the work, and that's why I've been working in this and so long. So CAS and the GAJC both began their work back in '97. We had two events that kind of led to it. We'll talk about in a second. CAS took a very data-driven approach. The GJC, which we'll talk about a little bit here, because it feeds into how the GA community and the rotorcraft community do their work. We took a slightly different approach, and it didn't quite work. We kind of worked whatever the action du jour was. So in 2011, we were asked, hey, can you bring the CAS process to the GA community? So I fly GA, but I worked in the air carrier world. So I got a chance to come over and kind of help bring the process over, and we'll show you in a little bit how that's gone over. Next. So CAS, like I said, the Commercial Aviation Safety Team, we had two very significant accidents in 1997. We had TW800 and ValueJet. They happened just a little over 2 months from each other. And at that time, there were two initiatives, the White House Commission on Aviation Safety and the National Civil Aviation Review Commission, NCARC. Both said, hey, industry and government, you need to get together, work together to reduce, at that time, they said reduce the fatal accident rate by 80% in 10 years. So I think that would have been 2008. And then also the projections out of the NCARC were, if at the rate we were seeing commercial aviation grow, and at the rate we were seeing the fatal accident rate climb, we were going to lose probably a air carrier size aircraft somewhere around the world, probably every week to month, within about I think it was about, if I remember correctly, about 15 to 20 years. It was a pretty shocking statistic. So we knew we truly had to work together and do something. And it was an opportunity for all of us to focus. Prior to this, there were a lot of initiatives. You'd see a binder wind up on somebody's shelf of, hey, we work this. Here's what they came up with. But it was kind of hard to figure out how we implemented. But this was a mean for all of us to try to come up with a methodology and a process to develop mitigations, and then continue to track those, make sure they had the desired effect. Next, Chris. So truly, everything we do is done through voluntary commitments. We apply consensus decision making through everything we do. We focus on implementation. When we put something in place, we as a community follow up to make sure it's happening the way it's supposed to happen. Make sure it's having the desired effect. If it doesn't, we go back and open it up and make sure it. Did we miss something when we did the analysis? Did something else occur? And then everything we do is data driven. Anything we do, any mitigation that we have, we can point back to an accident or a study that we've done. And in the end, as a community, whenever somebody asks the FAA or one of our associations, whether it's on the commercial side, whether it's on the rotorcraft side, whether it's on the GA side, as a community, we can pick up the safety enhancements, the mitigations that we develop out of this process, and say, hey, this is what we as a community are doing to reduce the risk of fatal accidents within our community. And so, like I said, we have the commercial team, we have the helicopter folks, we have the GA folks, and now the drone safety team is just well, they've been starting up for a while. They get the benefit of really no fatal accidents, so they get to concentrate more on kind of what we're talking about here, which is the proactive side. But that work is ongoing, and really starting to spool up now. Next.
All right, thanks, Corey. So I'm going to talk a little bit on the helicopter team. So the U.S. Helicopter Safety Team, it was established in 2013. So once established, there was an initial accident study that occurred, and the purpose was to identify the most common causes of helicopter accidents. So the results highlighted three major areas of concern, and those are what was represented at the top three bars of the USHST Pareto chart, which was loss of control in flight, unintended flight into IMC, and then low altitude operations. So based on those findings, the USHST developed a number of helicopter safety enhancements, which were eventually combined or reduced down to 16 HSEs. And those were designed to address and mitigate the identified risk associated with those top three areas of concern. So by the end of calendar year 2022, all 16 had successfully been implemented. So kind of the important point to make here is recognizing that safety is an ongoing process. The USHST has continued to reevaluate recent accident data to ensure we're focusing in the correct areas, which led to the development of these 5 new HSEs. So the 5 ones down there in yellow or orange, those are the ones currently in the works. Next slide, please.
Cool. Thanks, Emily. And so the work that we do, whether it's kind of the forensic accident work, whether it's the proactive size type work that we're talking about here today, it's all very similar. We conduct as a community data analysis. So as a community, we agree on. Oh, go ahead, Laura. Sorry.
We have an attendee who is wondering what an H-SE is.
So those are the helicopter safety enhancements.
Yeah, a safety enhancement is a so what we couldn't be simple, just call it a mitigation. We wanted to try to when we were doing the cast work, we called our mitigations safety enhancements, and the reason for that is a safety enhancement can be made up of multiple mitigations. So we came up with that name. So we've used the safety enhancement kind of nomenclature throughout the process. The helicopter folks, just in order to separate it from ours, so we don't get the numbers confused, use HSE.
So the HSE is one of the products of the U.S. Helicopter Safety Team. And even if you're not a helicopter pilot, this is a treasure trove of information for flight instructors, student pilots, seasoned pilots, new pilots. It's all the data, they're white papers that have been written about the data that we've looked at in these accidents. And if you go to ushst.org, or just Google USHST HSE, it'll take you to that portion of the website, and you can download these. Obviously, they're free. They've been a collaboration between industry, the FAA, the NTSB, to come up with these enhancements that you can read to help you avoid accidents or situations where we have learned can cause loss of control, inadvertent IMC, how to prepare for night flying, the use of simulators, the use of EFBs, all kinds of stuff like that. I'll let it go back to you. Just wanted to jump in and show folks where they could find it.
No, Chris, thanks so much for that. And I also put in the URL for if you're fixed wing, for the GA side. We've done we'll talk about a little bit here, some of the work we've done, similar to what Emily just kind of covered with the USHST folks. So like I said, no matter what we're doing, whether it's working with proactive work or proactive systems or working forensic, we use the same process. So as a community, and when I say community, I mean industry, whether it's different associations, also the FAA. That's when I say community. That's all of us working together. We do data analysis. We all make sure that we agree on what the issues are and what the defined interventions are. And then from there, we set our safety priorities. We decide what interventions are going to have the best bang for the buck, and we make sure that those get the resources that they need to come to fruition and hopefully make a dent in the fatal accident rate. And then we implement those here in the U.S. And then we also share those worldwide. So we have teams that do a lot of outreach work around the world. I work with our Brazilian folks on the GA side. I also work a lot with our friends in Europe and some of the Commonwealth of Independent State folks. to share what we learn. But then it's not a two-way; it's a two-way street. We don't corner the market on safety. So they may come up with some other organization has come up with a better mitigation than we have, and we'll take that back and put it into our process and see how it works. What works with us. So we're always willing to share, and we're always willing to learn. So next, Chris. So, like I said, everything we do is made up of government industry. There's never a part of our work where it's just one side, whether it's FAA or industry, running in a direction. These processes are also developed to make sure that not one organization's agenda can kind of take precedent. Everything our scoring for our problem statements for our interventions, the process for developing our mitigations, it's all done so that it's a level playing field for everyone participating. And as you can see, we have all the different lines of business within the FAA. We have a lot of the associations within the GA community. NASA helps us out with our research. A lot of the universities help us out with our research. NTSB is there as an observer. EASA, Transport Canada, they're observers. ANAC, our Brazilian friends are there as observers too. But then also, like I said, we learn a ton too. Example is with our Canadian friends. Between our friends in Alaska and Canada, they taught us a lot about weather cameras that have been used in Alaska for quite some time. And we found ways to bring those down into the lower 48. And it's because of what we're able to learn and bring back. We made a huge advancement in bringing those technologies down to the U.S. And if you look at the Weather Camera Program Office page now, you'll see quite a few weather cameras in the lower 48 and pass cameras. It works great. Next, Chris.
All right, and here is a depiction of the USHST steering committee. As Corey and Chris have both stated, safety is a collaborative effort. So you can see we have our equipment manufacturers, we have our industry, our academia, our government, all working together to enhance safety across the rotorcraft community. And Chris added a QR code there. That is the most recent issue of our FAA Safety Magazine. And there's a whole chapter in there on the USHST. So feel free to check that out. A lot of good information in there. Next slide.
Thanks, Emily. So everything that we do on whether it's in the commercial world, whether it's in the GA community, whether it's with the rotorcraft folks, the Pareto is what kind of guides our work. So gives you an example of GA fatal accidents from 2013 to December 2023. And the reason we kind of have an offset here is if we go too sooner, it usually takes the NTSB a year or two to finish up a GA accident. Some go quicker, some take a little bit longer. And the reason for that is, the board, they may have to do an engine tear down. They may have to do some component testing. It takes a while to do a lot of that background work. So in some cases, it can take a little bit of time. If we go sooner, you'll see two categories: unknown and other. Those can kind of grow. So if you look at this example, loss of control, in-flight loss of control is by far our largest fatal accident type in general aviation. Any dent we make on that bar, we make a significant impact on the GA fatal accident rate. Next down is it's called system component failure power plant, but it's anything that's engine related, not fuel related, but engine related. Unknown in this case could be anything from, hey, we found a smoking hole in the field. We did the control checks, everything looks fine, or there's nothing truly definitive that the NTSB can hang their hat on to say, hey, this is exactly what caused that accident. We have a lot of factual information that we can gather, but there's nothing that we can say definitively that this is for sure the cause of that accident. This could also be, so be said, between unknown and other. If the accident's taking a little bit longer to close, that could be why those bars are slightly higher. Next up is controlled flight in terrain, unintended flight into IMC, fuel, and system of failure non-power plant. So that's any mechanical issue on the aircraft that wasn't engine related. That kind of gives you this chart kind of gives you an idea of what some of those categories we look at. But these are the things that truly guide our work. So we can when we work our way from the left to the right, we know we're working from our highest we're kind of our highest number of fatal accidents at to our way down. So we're concentrating on where we can save the greatest amount of life by doing this. Next, Chris. And as you can kind of see, by doing so, we've done these studies to date. So like I said, we started off with loss control. We did our first one was done in approach and landing, just as a test case to see if we could bring the process we'd use in the commercial world over. It was successful. Everyone in the industry and the FAA agreed that, hey, this process worked for GA. We weren't sure at first, but it was successful. Then we looked at loss control, other phases of flight. So we came out with 23 mitigation safety enhancements out of the first study. We did an additional 6 on top of those 23 when we looked at the additional after that. Our next study was looking at those engine issues we talked about a minute ago. We developed an additional 11. So those previous 29 SEs, some of those were applicable to the engine world. There were some things that were so unique with the engine issues that we developed, like I said, another 11. After that, same thing, controlled flight and terrain. There were some things that came out of those previous studies that were applicable to CFIT, but there were at least 6 unique things that we found that we developed new enhancements on. And we just finished our non-power plant. So like I said, any mechanical failures not related to engines. We just finished that study. 12 new safety enhancements were just voted on by the GAGSC and went into our plan. And those are in the process of being implemented now. Next.
All right, and as Corey described their Pareto, this is the U.S. helicopter fatal accidents by occurrence category, and this is from 2021 through 2025. So as you can see on the left there, low altitude operations, UIMC, and loss of control in flight. Those are our top 3 leading causes of fatal accidents. And I want to specifically mention that because if you think back to the first slide I briefed on our helicopter safety enhancements, these are the same 3 topics that were at the top of our Pareto nearly a decade ago. So if you see that red line there, you can see they make up 61% of all fatal accidents. So that really just shows us how important it is for us to continue to work through the helicopter safety enhancements and work toward reducing the number of fatal accidents. Next slide.
Thanks. And it just kind of give you an example of what some of our mitigations are. So there's never one single silver bullet. You can't solve everything with technology. You can't solve everything with training. You can't solve everything with outreach, but it's a mix of all those things that kind of help us improve safety. So here's an example of one that we developed for GA, and it was so successful when our rotorcraft friends did their study. They're like, hey, this worked out really well, and was adopted by them also. Chris, next. So we had a room full of folks with us when we did this. This actually came out of loss control when we did the study, and we had one of our CAMI docs, our Civil Aviation Medical Institute doctors, with us, and we had, like I said, we were all a mix of pilots and safety folks, or like my case, a little bit of both. And then he asked us, he's like, what? After you take a medication that contains something like diphenhydramine, the main ingredient, active ingredient, is something like Benadryl or Tylenol PM or one of those that can cause some sedating effects. How long do you think it is until you can safely fly? So he asked around the room. Most of us took it again every 4. You take it every 4 to 8 hours. 8 times 2, 16. 16 was kind of the average answer for almost all of us. And the doc goes, well, actually, for something like that, you have to take 5 times the max, dosal, which is like 40 hours, 5 times 8, 40 hours. None of us got that right. We were amazed. So we figured, hey, if we don't understand this, here's a group of safety folks and pilots, probably the rest of the community is in kind of the same boat. So our friends in aeromedical had a document called No Fly, No Issuance, which was kind of medication guidance that they gave out to the AMEs. So we decided, hey, is there a way that we can make this pilot friendly? And since we were pilots, it's like, how do we make this friendly? It's like we add pictures and we colorize it. And to make it easy in typical pilot, blue. Goof that up. Green good, red bad. So if I'm in at CVS at 10 o'clock at night, and I've got allergies, and I'm trying to figure out what I can take, and the pharmacist has gone home at night, this document, which it stays in a central location, all of our associations and all the different parts of us that utilize it, we linked to that one single document. So when it's updated, everybody gets, everybody sees that same document. They get the updates, everything. So if I'm sitting at CVS at 10 o'clock at night, I'm trying to figure out what I can take. I've got guidance on the first page that tells me how to read, the important drug information, just as a little bit of background. some additional, pertinent safety information kind of on the second page. And then on the third page, if I by third and fourth pages by condition, I can take a look what I'm kind of interested in. Green tells me what are things I can take. What are red tells me what are things I should stay away from, and then any pertinent notes from the aeromedical community that we may want to know. And it's been very beneficial. Next page, Chris, or slide, Chris. And so if you're interested in this, there's link on several association websites. We also have links on the FAA website. You can look this up, but here's also the QR code if you want to take a quick picture. And then if you're at Oshkosh, please, by all means, swing by the FAA Safety Center and stop by and say hi. We also have these on our boards there. And this has been probably one of the more popular things. I do volunteer work with the Civil Air Patrol, and I've actually used this within our wing here in West Virginia with our vehicle drivers, just to kind of give them some guidance, because it's actually really good guidance for anybody who's operating a vehicle. But then also we try to get it out to the broader community too. And a lot of schools will take this. They'll get it out to their instructors to get it out to their students, because that's a good reference for them too. And then, so if you take a look at these safety enhancements, what kind of effect have we had? So you can kind of see the red line is for the GA side. This is what our fatal accident rate's been over time. The blue line is what we were shooting for. So in 2011, we were asked to bring the process over to the GA community. 12 and 13 is when we did our studies. We had our first safety enhancements hit the streets about 13, 14, and we saw the numbers finally dip below our target, our reduction goal in fiscal year 15. And if you go to the next slide, Chris. We have continued, luckily, fortunately, below that. And as of this week, we're at 0.45 is where the current GA rate is. And for those of you that fly out, this is good news. This is the lowest the GA fatal accident rate has ever been since we've been recording these numbers in the methodology we do. So the denominator is our flight hours coming out of the GA survey. So congratulations to all the folks that are out there that fly out in the system. You're doing great. Continue to do so, please. Next.
Yeah, thanks, Corey. And this is the USHST fatal accident rate, and ours is from this shows 2011 to 2026. So the numbers like the 0.8 or the 0.7, those are per every 100,000 flight hours flown. So overall, we do have a slight downward trend over the last 15 years or so, as you can see by that dotted line there in the middle. So we have difficulty sustaining these decreases in the U.S. Fatal accident rate. So it's kind of evident if you look in the 2014 to 2017 range. We were able to reduce the number and maintain it for a few years, but then you can see it goes up again for another kind of 4 years and stays up. So it is an ongoing challenge. We want to reduce the number and then be able to sustain it. So in 2014 is when we hit the lowest that we have on record, which is the 0.42 there. But then you can see in 2025, it goes back up again. So we do have the 16 helicopter safety enhancements, as well as the 5 that are ongoing, trying to reduce the number of accidents. There are multiple programs out there. So if you look at the USHST website, there's a lot of initiatives. We have the Peer Pilot Program, the 56 Seconds to Live initiative, which is linked to UIMC, Fatigue Risk Management Program. And again, we've introduced the SIAS. We're going to talk through that more here in a few minutes, but these categories right here are really what drive our work in the SIAS. So again, we have a slight downward trend, but it's really not as steep as we would like to see. So again, safety is a continuous process. So it's something that the UST is really focused on and continuing to work. Next slide.
And just to give you guys a quick heads up, Dr. Lee Hattrop, who's one of our headquarters docs, who's online with us this morning, just sent me a note that the diphenhydramine number is actually 5 times 12, so 60 hours. So thanks, Lee, for that. For some reason, I always remembered it as 40, but I always go to the source. So thanks, Lee. So one of our other safety enhancements is SC22 and HSC82 flight data monitoring. So we had success with, go ahead, next Next slide. This is where it helps to explain this one. So we have reactive and proactive. So when we did the CAST work, so like I said, the commercial aviation safety team work was done first. Did the accident investigations, we reviewed the accidents, developed our mitigations out of that. When CAST was done, and CAST was successful, they were supposed to reduce their accident rate by 80%. By the time they ended, we'd actually ended by between 82 to 83%. So they were very successful. We had to decide, what do we do? Do we disband? Do we continue our work? And it was decided, hey, let's continue the work. We got all the right people together. In the meantime, while we had been doing this analysis over the years, we'd had FOQA and ASAP and other type programs grow, which are flight operations, quality assurance, and aviation safety action programs. So that's flight data from aircraft, and that's pilot reports and crew reports saying, what we always say is the FOQA tells you what went wrong, the ASAP tells you why it happened, why it occurred. So because we had a lot of those programs continue to build, we had a lot more carriers with those. We decided, hey, let's use those data from the operators, and then let's use the FAA bring about 145 different data sources into the mix ourselves, and then other operator and manufacturer data together, and let's try to see if we can, what can we detect what that next fatal accident is. And that's really where the work that we're talking about today was born out of. So this is where we take all these other data together and try to determine what happened to be more proactive. Next, Chris. And by doing this, our goal is to really go from what went wrong to what could go wrong. So rather than starting off with the accident, take a look at the environment. Look at all the different things in this picture, and then use the data that kind of point to risks that we're seeing, and find ways to implement those before they become the photo on the left. Next. Emily, come over, this is me or you. I'll go ahead. So we have a pretty diverse stakeholder base. So we start off with two airlines at the very beginning. We're up to 45 now. We began with very similar. We started with two corporate business operators, and we're up to 162 now. Start up on the rotorcraft side, I think it was something similar. You're up to 9 active now, and that number will be growing here, continuing. 32 industry, and that's a lot of the associations. So on the air carrier side, it could be A4A, AIA. On the GA side, GAMA, General Aviation Manufacturers Association, AOPA, EAA are very active members. International, EASA is I think kind of the official member, but we have others that participate as observers. Government, so FAA, NTSB, VOLP, which is a part of DOT, DOD, just to name a few. Maintenance, so Part 145, MRO type folks. Manufacturers, Boeing, Airbus, Textron, Gulfstream. And then we also have Bombardier and Embraer participating in various studies. And then universities. Universities are very active and are on both the fixed wing and the rotor wing side, and do a lot of work on both the FDM side and the ASAP side. Next. So we've been doing that work, like I said. So the commercial size work began in 2008. 2013, we began the GA side. We're now expanding this, of course, to other operators. We're in the process now of bringing about what we call size 3.0. We've had a lot of changes in the system. Data has changed. We have a lot more data. We need to find ways to go through those data and try to gain insights faster. If you're overcome by the tidal wave of data, you need to make the tools that can help you sift through and help you identify those risks a lot faster and a lot easier to use. And so our goal is to try to make it as real time as we possibly can get. There's some lag in certain data types, but we also have data that we have instant access to. And are there certain things that we can do with those data that we can identify risks much quicker? Next. So Okay, yeah. Okay, go ahead and go through until we get to, yeah, there you go. So the work we do, and also going forth into 3.0, everything we want to do is collaborative. We, as a community, want to identify hazards and risks together. We want to analyze those data together, share with each other, make it a safe environment and secure. So all the data being brought in is safe. We want everyone to have access to the data that we bring to the table. When we use those data to what we call fuse data sets, we can kind of do combined parameters by bringing different data together and bringing more value to that. We're finding uses for AI tools to help us identify and help us bring things to the surface much quicker. We want to integrate and, like I said, infuse as much like things like SMS or other safety program data to help operators and airlines and individual pilots produce self-service metrics and benchmarking. So if you are looking at your unstabilized approach rate and you want to know how your unstabilized approach rate is against the broader GA community, we've got tools that can help you with that. And we want to help the speed too. We want to help bring rapid ingestion of data. If we have a new data source that can help us identify a risk or help us better visualize, what it means to the community. We want to help build the tools that will bring that to fruition much faster. Next. And everything we do, we have very formal principles, and we do that so everyone feels comfortable. So when we first started this work, and I was at Alpha, I'll tell you, we kind of had some arguments inside the building. It's like, you want to share data with who? Are you nuts? Really? Have you told Dad? We really wanted to try to find we want to try to spell out the protections as much as we could so people felt confident. Sorry, it's coffee and wings, so I felt obliged to give them some coffee. So we spell out that data is used solely for the advancement of safety. Everything that's brought in is voluntary. So if there's something that folks are concerned about, they don't have to bring those data to the table. If they want to bring it in, it is protected, and they know that. But there's some cases people are like, yeah, I just don't know if I want to share that. That's fine. You don't have to. It's not required. Everything's transparent. We want people to know how the data is being used, where it's being used, and everybody has a say to that. So any analysis we do, it's approved by leadership, and that leadership is made up of industry and the FAA. It's not one group saying yes or no. It's everyone together, and it has to be unanimous. And we have spelled out policies and procedures kind of on the collective governance. So these rules were developed by the community, and then they're maintained by the community, and we make sure they're enforced. And then any data that's brought in from any of the communities into the program are de-identified. So no one can be tracked down. You can't identify a flight, you can't identify a flight crew, a pilot, you can't identify an operation. We're looking at the forest, not the trees. Next. And so the protections are, like I said, are very important to us. So we have, like I said, we have specific rules and protocols on de-identification. We have rules and guidance on how long those data can be kept, and that's agreed upon by the community. Different segments have different retention. Like on the GA side, I think we're good for 3 to 5 years because the community said, yeah, we're comfortable with keeping data that long. We want to keep the data that long. Because it helps the operators when they kind of compare, and it helps the community as we start looking, like I said, once again, at the forest, not the trees. MITRE is a kind of the trusted third party. They're outside of the government. They kind of have the contract to help bring those data together. So they work with all the different pieces that ingest data, whether it's from the commercial side, whether it's from the rotorcraft side, whether it's from the GA side, and now coming in the future in the drone side. And others won't have access to your data unless you agree to share it with them within like a sandbox. We have collaborative enclaves, which are sandboxes that operators and the community can use together to, hey, we want to go look at low airspeed on climb out. Let's go do that together. And we can build a sandbox, and those that want to bring data in, work together on that can. And so the benefits to the stakeholders are kind of better focused with cross-community capabilities. We can action safety insights, intelligence quicker. We can, like I said, build those sandboxes so we can conduct specific analysis that we identify. And folks will have access to data that we bring in, and then integrated data sets which are brought in by the operators too. Next. As you can tell, I can wax rhapsodically about this stuff all day long. So how does the process work? So you as an operator, or you as an individual pilot, or even an airline, they collect their data. So the airlines are coming off QARs for the smaller operators and some of the rotorcraft folks. It could be anything from avionics. It could be like a perio camera if you're operating like one of the Airbus helicopters had installed, or even portable devices. It could be an EFB. It could be an app like Chris is about to talk about. Next. And then you, as the operator, or you as an individual pilot, you're going to be interested in the trees. You want to know your data. The purpose of these tools and some of the commercial tools that are off the shelf out there, those are there to help you identify, what are the risks that you're seeing in your operations, because that's where the true value is. And then also in other tools, and then also in the size tool set like we're looking here, how do you compare against the broader community? What do your benchmarks look like? What are some other tools, like the tool on the left there with the green lines? That's a turn to final tool. If you were to zoom in on that, you can kind of see some red and some orange, and that's telling you, hey, what's your risk of loss control during turn to final? The other one's a stabilized approach tool. So tools like that help you understand. So this is the trees. Next. And as a community, we're interested in the forest. So that's where we as a group work together to identify risks. What are the issues? And then act upon those and put out. So like I said, you're looking at the trees. The community as a whole is looking at the forest. We can't identify a single tree out in the forest, but we want to know what are the trends and what are the issues that are leading to potential issues. And I think, Chris, you guys are next.
Yes. Oh, thanks, Corey.
No, thank you guys.
As Corey alluded to, we wanted to come up with a tool that GA pilots could use. And Hughes being non-denominational, we don't care if you're flying a fixed-wing aircraft or a helicopter. We wanted to give you a tool that would help you better collect FOQA data and give you a post-operative analysis. Before I jump into that, this tool, the Hughes app, is free, doesn't cost anything. There's a QR code there that'll take you to iOS where you can download it and set it up. If you're able to, when you sign up for the Hughes tool, you can join the U.S. helicopter safety team right there in the app and get a membership card. You don't have to be a helicopter pilot or a helicopter mechanic to become a member of the USHST and get all the benefits of the safety tools that we have. One of the tools that we recently added to the app is a VFR prediction tool looking at inadvertent and unintended IMC. Just as a little footnote, I've been flying since 1978, and on my first solo cross country, I went inadvertent IMC. So it can happen at any point in your career. My determination after I landed that day was that I was going to become the best instrument pilot I could be. The VFR prediction tool is a tool that you can put in your airport, heliport, a lat long. You can even draw on the map with your finger what your route's going to be. And the VFR prediction tool will go from current time out to 24 hours and look at all of the weather in a boundary box that it creates. TAF, METARs, if there's an FAA weather camera anywhere along your route, it'll pull that for you. And you can tap on it and look at the view. It'll also pull NOTAMs for different airports that are along your route of flight in case there's a NOTAM of interest that you will not miss. Even better, we added the slackline tool. So there's a slackline layer in our map feature that you can toggle on and off, and it'll pull slacklines for you, even if you don't have it turned on, and you can tap on it and it'll open up and show you where the slackline is, what it looks like. until the accident on January 2nd, I never heard of slack lines, but there's 7,000 slack lines out there. And this tool will help you find them so you wouldn't have an inadvertent collision with one. That's the slackline tool. Bill's going to talk about our Folkwa tool that we also recently added and how you can use it to collect data.
Thank you, Chris. Can you hear me?
I got you loud and clear.
Cool. So yes, the Folkwa tool, like Corey was talking about, is a tool to collect a lot of the sensor information that is available to an iPad or an iPhone. And we made it nice and simple, dead simple, like even easier than a VCR to make it work. From the left side of the screen here, you'll find the menu item on the screen. You'll end up clicking on the record button. When you click on the record button, there'll be a setup screen. You enable or disable the sensors that you're interested in, and then you tap the record button. The recording screen is a typical six-pack. It's taking all that raw sensor data, making it into a little bit of a visual. It also works in the background. So if you go to a different app or you just put it in sleep mode or whatever, this you can see on his home screen here, you have these little buttons to maybe mark turbulence, or maybe you're doing some sort of a maneuver and you want to mark that part in the recording. The last screenshot there is the recording details, where you can do a playback or maybe even upload it to a SIAS for additional analysis.
So that is something that we're working on with the FAA actively for this upload to a SIAS feature to work, where you can share this data de-identified with a SIAS so they can better understand how we fly and where our markers are, if you will, both the trees and the overall forest. Just to steal something there from Corey.
One of the cool things about the analysis is this Folkwa. We built an AI to do this data fusion. So look at all the sensor information, look at the weather, look at the category of aircraft, look at all that data through deterministic lenses, and create summaries for you. What was the weather at that time? Were your bank angles too steep? Were your vertical acceleration too much, right? You have all these thresholds, and once you start exceeding them, it identifies it and gives you a plan of what to look out for, things like that. And of course, you got the playback where you can play back the flight, see the track on a map, zoom in and out, see what the raw sensor data is or a visual, and a scrubber, just like a VCR. You can play it back at multiple speeds or just slide the scrubber with your finger.
I'm going to start the video, Bill, if you want to walk us through this.
I'll talk to this as it's going. We'll just go ahead and log in, basically. You'll go to navigate back to the main menu. You'll find the Folk One flight recording menu item. Tap on it. They're going to take you to a screen where you see a list of previous recordings. Those green dots say, hey, everything is uploaded. This is all your different options. You can see things like date, duration, playback, analysis. We can go to a playback screen where you'll be able to zoom in and out, see the track of your flight, see what the different instruments are doing. You got the slider control at the bottom. If you end up going back, you might want to look at the analysis report, your summaries, looks at things like data quality, timeline narrative, METAR reports, event highlights, confidence statements. It'll even detect things like, hey, you removed it from the mount. So it's really looking at a lot of really cool things. After you view your analysis, you might want to share it with the world. And once you go back to the next screen, you will be able to upload it to a SIAS. You can view their portal information if you have a log on. You can enter optional information about the aircraft or pilot. You can add notes to this recording, and then you can include or not include certain things. Like maybe you don't want the cockpit audio in there, or you don't want your events in there. And then you tap the upload button, and then it goes up to a SIAS. One of the next things would be probably to just actually do a recording. You can pick your category, fixed wing or rotorcraft. You pick the sensors you want to start, maybe your sampling rate. You change that, and you tap the record button. It's really that simple. You confirm, hit the green start, and it starts recording. One of the first things you're going to want to do is put it in a mount and then tap on the cage button. You notice this from a lot of other avionics. You cage it, leave it in a mount, and it starts recording and basing everything off that one baseline. Um, One of the things that also, oh, and then you got the status here too. If you're interested in looking at the raw sensor data as it's collected, it also does things like tries to determine where, what phase of flight that you're actually in. And of course, again, you got the zooming in and out. Right now it's showing just VFR, but we have other maps. If you go to the background, here's a real working example. I can click buttons. You click on any of it, takes you right back into the recording. Once you click the stop button on the recording, it will upload it privately to your iCloud, syncs across all your other devices. You get to see if where it is in the queue for the AI to analyze the information and give you feedback. It'll send you an alert, but only if you have alerts turned on. Here I had it in do not disturb. I took it off of do not disturb. An alert came in telling me the AI is finished. It's ready for you to analyze the report. And then here is the report. It's really that simple.
So here's some more QR codes that you can take a picture of. That'll link you to the GAJSC and also the rotorcraft ASIAS and flight data monitoring. These were provided by the FAA. There's a QR code for the same and for the U.S. helicopter safety team. We're just super easy to find. It's just Google USHST. It'll take you to our web portal. When we talked before too about these HSEs, we've turned many of them into either a 3-minute video that's on the Rotorcraft Collective, and you can go to that channel and watch them. Podcasts that we've done to that you can listen to in your car or while you're walking the dog, if you don't want to sit down and read the whole white paper. So it's just another tool that you can use to understand how there's an interrelationship between, accidents, the actions that we take as pilots, the actions that are taken in a post-operative analysis, and how we can distill that data to avoid having accidents ourselves. So, Laura, we'll open it up to Q&A with the time that we have remaining. We've got about 5 minutes.
Yeah, so there were several questions people had about the GA data, and let me find those. A lot of questions about what causes the accident rate to go up and down.